Understanding the density of water is very important because it tells us about how certain things in our environment function. Well, you guys might know that density is how much mass per unit volume of a substance contains. So let's take the example of these two substances. One substance has more mass per unit volume, while this substance has less mass per unit volume. So in the same volume, if one substance contains less mass, that means that it is less dense, and the substance that has more mass per unit volume is more dense. And usually, if we mix a less dense substance with a more dense substance, so the less dense substance it floats over the more dense substance. So substance with high density it settles down below, and the substance with less density it floats over the substance with high density. Mathematically, we can say that density of an object is the mass per unit volume of the substance. And density is represented by this symbol that is known as a rho sometime, RO rho. And it's equals mass per unit volume. If we talk about the density of water, so density of water is very high, approximately 1000 kilograms per meter cube. Well, the density of ice as compared to water is less, approximately 900 kilogram per meter cube. And well, so a question arises here that ice is solid. So usually solids are denser than the liquids, and water is liquid. So why does the water here shows a peculiar behavior? So the reason for it is the structure of the arrangement of water molecules in ice. Well, we know that in water, water molecules are very randomly placed, right? They are very close, they stick together, and they share very strong bonds with each other. So that is why their volume is less as compared to, the volume between the water molecules in ice. Because when the ice forms, I mean when the water it converts into the solid form, the molecules of water they arrange themselves in these hexagonal rings type structure, and when they arrange themselves in this hexagonal ring structure, they they have more spaces between them than usual in the water, in the state of water or in liquid state. So because they get more spaces in the solid structure, so their volume increases. And we know that density is inversely proportional to the volume. So if volume increases, the density decreases. So because ice has more volume because of the this structural arrangement of the water molecules in ice, that is why it has less density than water. So you can see here that the same volume of water contains more molecules than the same volume of ice. It means that ice is less dense while water is more dense. And I've told you guys that a less dense substance it floats over more dense substance. That is the reason why ice floats over water. So, if ice floats over water, why is that significant for us? Well, this phenomena or this aspect of science or our environment is very important in terms of cold climates and maintaining the temperatures of water in the cold climates. So, the summary here is that in much colder climates like those of Antarctica, Arctic, or many other regions where there are glaciers and lakes in the more colder regions. So the upper layer of water it usually contains ice, and the warmer water, its molecules. So the the less density or the water in in terms of density, the least denser is the ice. Then warm water has higher density than the ice, and the cold water has the highest density of all of them. Because in colder water, molecules are present even more closer than in warmer water. So in warmer water, molecules are present at distances. So they have larger distances between them as compared to the colder water. So that is why cold water has the highest density. So we can assume, or we can, just suggest that in colder climates, the more colder water is present at the bottom, the warmer water is present above the colder water, and then above warmer water is the layer of ice. Well, this is very significant for aquatic life because aquatic life, most of the aquatic life, it dwells in this region of the water body. Okay, so this is the region in which most aquatic life, so most of the aquatic life, it dwells. So how does this whole process occurs? Look, so ice, it water, it starts turning into ice at 4 degrees Celsius. And at 0 degrees Celsius, so the ice, it just starts forming, and at 0 degrees Celsius, the water, it completely freezes into ice. So when the temperature reaches 4 degrees Celsius, water at mostly the upper level, it does not convert immediately to ice, but because temperature in the environment is getting lower, that is why the first layer of water to freeze is of course the upper layer. So upper layer of water here, it starts to freeze because of the temperature getting lower and lower. So it starts becoming ice. Now once it has become ice, the lower layer of waters, these layers, they don't turn into ice. Now, the question here is that if the upper layer, I mean, the temperature is getting lower and lower, and the upper layer has completely turned into ice, so why don't the lower layers of the water turn into ice? It's because of a very special property of ice, and that is ice is an insulator. Now, if you guys remember from your previous years of study, insulators are the substances that do not conduct heat or electricity. So, if they don't conduct heat, it means that they don't allow the temperature or the heat of the warmer water present below the ice to get into or to get lost into the atmosphere, or it does not allow this water to become cold. So this water that is present below the layer of ice, it remains hot. And in this diagram you can see that at 0 degrees Celsius, when the temperature reaches 0 degrees Celsius, the upper layer of the water is first to turn into ice, but the lower layers of water, they remain from turning into ice. And they the waters below the ice, they are warm, and these warm waters, they provide temperature, moderate temperature for the life, for the aquatic life to dwell there. So this is very significant in terms of aquatic ecosystems Also, you can imagine that what would happen if the ice would not float on the water but it would sink in the water. Then we would have huge glaciers underwater, and the water of all the oceans, they would just overflow, and all the land would get covered with this water. So um it's very beautiful fact. It's a beautiful and astonishing fact that how ice, even being solid, it just floats in the water, that prevents the water from not, overflowing on the land, and also keeps the aquatic life warmer because it keeps the water present below it warmer, because the ice does not let the heat of the warm waters below outside.